getting into Chapter 3, Parallel and Perpendicular Lines. We're looking here at day 1, which will be proofs with angle pair theorems. So at this point, we have gone through these proofs or these theorems before. And remember that all of these theorems start off in the same manner, that if two lines are parallel, cut by a transversal, then the corresponding angles are congruent. If two parallel lines are intersected by a transversal, then the alternate interior. If two parallel lines are intersected by the transversal, the alternate exterior angles are congruent. And if two parallel lines are intersected by the transversal, then the corresponding interior, same side interior angles are supplementary. Now, so what that tells me is when we look at the proofs of these, we're going to be given the fact that two lines are parallel, and then we're going to use these theorems to go about proving that angles are congruent. Okay, so let's take a look at this first one here. So here, let's mark up our diagram. So we're going to start off, we know that W and R are parallel. We also know that P and Q are parallel. Okay, now, the thing I always like to do too is I always like to look ahead and say, okay, what am I trying to prove? Well, here I am trying to prove that 2 and 15 are congruent to each other. But when we look at 2 and 15, they have no relationship at all because you're looking at two completely different sets of parallel lines, two completely different transversals. So what we have to look in this case is we have to look for an opportunity to find where would an angle have one of those four relationships corresponding, alternate exterior, alternate interior, or consecutive interior to both 2 and 15. So if we look at something like that, I'm going to start here at an angle 9. Now, when you look at angle 9, just for example, does 9 have a relationship with 15? No. So therefore, we know we're not going to need 9. So let's go to another one then. So what about if we did 13? Okay, so if I look at 13, 2 goes to 13. Those are alternate exterior angles. 13 and 15 are corresponding angles. So that is one possibility. There are several here though. Like for example, you could do angle 4. Angle 4 is corresponding to angle 2 and it's an alternate exterior to angle 15. Okay, you could also do angle 7, alternate interior to 2 corresponding to 15. You could also do angle 10, corresponding to 2, alternate interior to 15. But I'm just going to do the 13. So I found that one first, so that's the one I'm going to use. So what I'm going to do is I'm going to start off. Now, remember, before we declare or use that theorem, we need to say that the angles are that. So let's start with angle 2. So what we're going to do is we're going to start off with angle 2 and angle 13 are alternate exterior angles. The reason for that is the definition of alternate exterior angles. Number 3 then, now we're going to use our theorems that we have. So angle 2 is congruent to angle 13. The reason for that is because the alternate exterior angle theorem that says if two lines are parallel cut by a transversal, then the alternate exterior angles are congruent. Okay, so now we have 2 to 13. So we have this one ready to go. So now we just need to link the 13 to the 15. So now I'm going to go angle 13 and angle 15 are corresponding angles. And the reason for that is definition of corresponding angles. Okay, then we go to number 5. Now that they're corresponding, then I know angle 13 is congruent to angle 15 by the corresponding angle theorem. Then, once we know that, now we have 2 congruent to 13, 13 congruent to 15. So right away, I know angle 2 is congruent to angle 15, and we could use substitution here. Now, when you make that last statement, always look back to make sure it is identical to what the proof statement is that you're trying to prove. Okay, and ours is, so that is our proof to prove angle 2 and angle 15 are congruent. Okay, let's try another one. Here again, we're going to start off. We have W congruent to R. We have PQ parallel to each other. Sorry, I think I said W is congruent to R. That's not true. They are parallel. I apologize for that. So W is parallel to R, P is parallel to Q, and I am trying to prove that angle 10 is congruent to angle 4. So now we look through, we try to find something where they're the same. I'm going to use angle 12. Angle 12 is both corresponding to 4 and it is corresponding to 10. So at this point then, we're ready to start writing our proof. So we're going to start here. Number 2, I'm going to get the 4 and the 12 together. So angle 4 and angle 12 are corresponding angles. And that is by definition of corresponding angles. Step number 3 now, we have angle 4 is congruent to angle 12. And that is because the corresponding angle theorem. Okay, now here's the nice thing about this. So we have 4 to 12. Now we're just going to put 12 to 10. And the nice thing, it's basically going to repeat these last 2 steps. Angle 10 and angle 12 are corresponding angles. Definition of corresponding. And then step 5, we know that angle 10 is congruent to angle 12. That is by our corresponding angle theorem. And now that we know that, we look back, we need angle 10 is congruent to angle 4, and that is by substitution. And that is how we use those angle theorems, those angle relationship theorems, to prove certain angles congruent when I'm given parallel lines.